We're looking forward to announcing our next speaker. It's Dr. Ravi Shalwa. You might have remembered him from the first presentation earlier today. But he is with ChakraTech, and ChakraTech is developing proprietary microbial bioprocessing platform technology to convert greenhouse gases and their derivatives into materials and chemicals. Specifically, the ChakraTech platform technology enables the next generation biomanufacturing of a family of biodegradable plastics, which naturally degrade across a wide range of end-of-life scenarios. So welcome, Dr. Ravi Shaula.
Thank you. Yeah, you must have missed me. But okay, we will start again. So before I start, let's address the elephant in the room. Why chakra? Chakra is a Sanskrit word. It doesn't do anything with the yogic culture. There is an overlap, but chakra means wheel, full cycle, representing our ethos of full degradability. And if you don't remember anything from my talk, just remember what we're doing. We're transforming greenhouse gases into biodegradable plastic. All right, so you already saw this too. There is a mounting crisis of conventional plastics across the globe. This is not a problem for India, which I'm obviously was very concerned about it. We have this coming here in Miramar too, and if you can't see it, you can at least smell it. And this is huge health implications for us. The data is working. All right, I'll stay close to this. So the EPA data suggests that less than 8% data. Sorry, not data. Less than 8% of the material gets recycled of what we think. This is older data. The recent numbers are close to 5%. And when we do think that recycling is the solution, there's a recent study from a Journal of Hazardous Material which showed that actually 5% of the plastic that actually gets recycled also ends up as microplastic in our water streams, contributing to even further problem. We thought that recyclings are solving issues, they're not. All right, so for those of us who are very self-centered, we all are. We are busy with our days. It's affecting our health now, and this is the first concrete data to at least to my. It has convinced me to full extent from New England Journal of Medicine, where we can see that inside the macrophages we are starting to see these microplastics, and also outside. And these were isolated from your arteries. So this is an Italian study, multiple hospital studies. So obviously very problematic. And also we can see lung samples we are inhaling, and I'm not showing those data because I don't want to weird you out. All right, so what's the solution? The solution is bio-based manufacturing. Turns out that nature has been making plastics for billions of years, at least millions. We don't have fossil samples to prove billion. So what you see here is bacteria, and in the white you see this plastic. This is a polyester. It's called PHA. It's nature's fat reserve. Just like we store our fat, this is how bacteria store their fat. And it's a polyester, and it degrades in less than 90 to 180 days. And in certain scenarios, you can also get it to degrade sooner. There's a bottle made out of it. It degrades in soil and marine environment. All right, okay, this is cool. If this is so cool, is somebody else working on it? Well, of course, you can bet the people have been working on it. So the company Danimer Scientific, based out of Kentucky, CJ Biomaterials is a Korean company. They use food crops. Danimer uses vegetable oil. CJ Biomaterials uses sugar, obviously threatening our food security. They don't use greenhouse gases. There are companies which use greenhouse gases as feed. Strain engineering. So actually the strains that Danimer and CJ both own, they're from a 1990 company which went bankrupt in 2014 with the oil crisis. So they own it. The strain technology is good, but there's room for improvement. Mango and New Light are still emerging, but that's since their focus is not strain engineering, they've been lacking behind. Similarly, for process technology, this has been for Danimer and CJ, been around for a while. Meanwhile, for Mango and New Light, there's a lot of room for improvement. But this is where we come in. We want to bridge process engineering and strain engineering. And this is how we are doing it. So ChakraTech is a microbial bioprocessing platform technology. What it means is that we're very concerned from start to end. We are going to strain engineer highest production of our polymer, take it all the way, and take it in a way that it's scalable. Also, we use cheap feedstock. We want to use greenhouse gases as feedstock, which can come from industrial off gases or even agriculture and municipal waste. as you know, that this is a big mismanaged area, and we need solutions for it. So ChakraTech, cheap raw materials, robust grain engineering, high performance materials. And I'm gonna show you more about what can be made out of this plastic. So just as a showcase, I'm showing flexible food packaging. This is the part that's least competitive, and also people will pay premium. And the last part is humans are concerned about their safety. So for food applications, we can target PHA. It's a big market, and we think that within a few years, well, 5 to 6 years specifically, we can start obtaining 12 millions in obtainable market. And that's just one use case. Actually, you can tune the properties of this polymer by changing the R, X, and Ns, which is in the chemical structure. Well, market also recognizes the opportunity for bioplastics. It's supposed to grow at a CAGR of 20%, and that's in the in US alone. In European market, we are growing at 20 to 40%, depending on what report you're looking at. All right, yeah, I expected this. This slide keeps on disappearing every time it shows up on a non-Mac computer. Anyway, so our genesis is at the intersection of chemical engineering, material science, and life sciences. And we really want to integrate all these disciplines so that we are successfully able to develop a scalable technology. And I have to show this. So the first time I ever pitched was at Equilis, and we had an excellent team. So I'm gonna tell you that since past 1 year, we have come along. We have come along to bring together industry experts. Brandon actually has made this polymer at an industrial scale, both at upstream and downstream level. Arun is helping us with the bio. He's kind of worked with the biodiesel company in India, so he's looking at India operations. And we have all the industry experts which we need to successfully take this, make this happen. We also have a great team of advisors who are keeping us on track. And I do want to thank the Policy and Strategy Entrepreneurship Lab, specifically Jim, who has taken, he's been showing a lot of support to us and helping me grow personally and in thinking in terms of a global business. Revenue, obviously, we're all interested in how does it make money. Well, so we're exploring multiple paths, including licensing the technology, B2B and D2C space, especially because we want to get cash flow positive the fastest. That's one of the things that we are keeping in mind, because our science can be so good, but if we fail, then we cannot make it a reality. So how can we make it reality? That's our goal. We have partnerships set up globally. We have Ingenious eBrain helping us on the market intelligence in India, Experiences for Mankind with branding, and PSC Lab, as I already mentioned. We are bootstrapped, and Equilis, we won a competition the second time, not the time when I showed me in different ways. We got the lab space, and we're going to be starting here in May, and we've been here in San Diego quite a bit. All right, so the timeline. I'm happy to announce that immigration issues are getting resolved, and my day one will be at Equilis will be on May 1st, and we are looking at about 2 years to get to the minimum viable product, and we are seeking to raise $5 million to get us there. And I will also show you the use of funds. Again, this is year 1 and 2. Basically, what you need to see is that R&D is the heaviest requirement of our funds, including personnel. San Diego is expensive. Financial projections, as I was telling you earlier, this is, again, we are in a bit of a flux situation. We are working on it. But I want to show you that our expenses, like any biotech, that's in the red. It's a lot of expenses. Then, I just want you to focus on the net profit, that in starting year 6, we're going to start making, we'll go cash flow positive. Lastly, I want to invite you to embark us on a journey to make biomanufacturing the reality for 21st century and onwards. This is, this technology, making polymers in general, takes a long time. But we together, I think as a society, we can make this happen, and I seek your help in making that a reality. Lastly, we got a $100,000 grant to get 20 interns this summer through San Diego. So if you know people interested in business, computing, and engineering majors, we're hiring interns this summer. And I look forward to answer any questions that you might have. I think I went a bit fast. No, I did not go fast.
Thank you, ChakraTech. And does anyone have any questions?
You all are polymer experts after my seminar. I take credit for that.
Wonderful. Well,
Which it can break down outside when you enter it to break down.
It does. So, let's say if it makes into the soil. So I'm going to give you one example. So there are bacteria in nature which make enzymes to degrade it. So let's say if somehow you had the bottle and it's slaying and rolling in this sand, it will degrade. It will also degrade. This is hydrophobic, mostly hydrophobic polymer. It will dissolve. It's not a good carrier for our favorite beverage, alcohol. So that makes it less optimal. And also, yes, heat. So this cannot make everything right now. So beyond a certain heat of, let's say, 200 degrees Celsius. Flexible packaging, like, for example, when you buy mushrooms, you can wrap it around the container.
Thank you.
But there's still a lot we can make with this, just to say. But obviously, it's not a solution for everything. Food, yes. And also, actually, hernia meshes, for example, are already made of this material, some of the biodegradable ones. We are trying not to get into the regulatory space because I don't have much knowledge about it. So I'm going to stay clear of it until we really need to get into it.
wonderful. Well, thank you so much.